Dominated strategy. A strategy one would never take because it leads to a worse outcome than some other strategy, regardless of what the opponent chooses to do. The row player wants large or positive numbers. So a row strategy dominates another if all entries in the row are larger than corresponding entries in the other row. The column player wants small or negative numbers. So a column strategy dominates another if all entries in the column are smaller than corresponding entries in the other column. Okay, I know that's kind of hard. And what's going to be hard about it is you're going to have to be able to switch your perspective back and forth between the row player who likes large numbers and the column player who likes small numbers. Okay, so try to get that through your head. Positive numbers are good for the row player, but not good for the column player. And negatives are the opposite. So number 3, simplify each payoff matrix if possible by crossing out dominated strategies. Notice, if you're the row player, you like positive numbers. So this 1, 2, 3 are all positive. So that's a pretty good row for you. Okay, I might not like this row 3 because it's got negatives, but what dominates? So you want to compare like individual entries. So compare row 1 and row 3. Winning 1 is better than losing 3. Winning 2 is worse than winning 4. So row 1 does not dominate row 3. But look at row 2. Winning 1 is the same as winning 1, but winning 2 is better than 0. Winning 3 is better than winning 2. So I know it's a tie right here, but there's really no reason why the row player would ever pick row 2 over row 1. So I'm going to say that row 1 dominates row 2. We can cross off row 2. So if I rewrite the matrix, you've got 1 and 3. Let's try this again. And the column player still has choices 1, 2, and 3. So row 1 was 1, 2, 3, and row 3 was -3, 4, and -4. Now let's switch over to the column player. Remember, the column player likes small numbers or negative numbers. Okay, so look at this 2 and this 4. Okay, these are not very good numbers for the column player. But check it out. This 1 means lose 1. This 2 means lose 2. So 1 is better than 2. 1 is better than 2 for the column player. -3 is better than 4 for the column player. So this column right here in either case is better than either of these two numbers. So column 2 is dominated. What about column 3? Losing 1 is better than losing 3, but winning 3 is worse than winning 4. So column 3 does not get dominated. Okay? Now, if you rewrite, the row player is stuck with choices 1 or 3. The column player is also stuck with choices 1 or 3. So look at the numbers in the matrix that are left. You've got a 1 and a 3 and a -3, -4. Let's switch back to the row player. Okay, that row player likes row 1 better than row 2 because winning 1 is better than losing 3, and winning 3 is better than losing 4. So row 1 dominates row 3. Okay. And so you're just left with those two numbers. But wait a minute. We can do more than one thing at once. Switch over to the column player now. The column player likes small numbers, so the column player is going to rather have this 1 than this 3. Okay? So I'm going to go ahead and dominate this right now. I'm just left with that 1. All that's left is that 1, number 1. And the row player is going to play row 1, and the column player is going to play column 1. So I simplified the matrix quite a bit. I went from a 3x3 down to a 1x1. You won't always be able to simplify the whole thing. Okay? Look at part B. Part B. I like that third row. That third row looks pretty good for me if I'm the row player. Win 6, win 4. Winning 6 is better than winning 3, and winning 4 is definitely better than losing 2. So that top row gets dominated. Okay. Winning 4 is worse than winning 8. The second row is not dominated. I don't see any more dominated strategies. Notice this game must be like some kind of coin flip, heads and tails. Okay. Look at your columns. 0 is better than 8, but 4 is better than 6. None of the columns are dominated. No more rows are dominated. So this is it. This is how it gets reduced. Okay. Look at part C. Part C, remember, you want small numbers. This is the game we just played, the rock, paper, scissors game, and these negatives were really good for the column player. In fact, -2 is better than 1, -1 is better than 0, and -2 is better than +2. We can see that get dominated right now. Okay. Now, if we switch to the rows, I don't know, is anything better? I'd rather win 2 than win 1. I'd rather lose 1 than lose 2. It looks like row 2 is going to dominate row 1. But is row 2 also going to dominate row 3? Looks like it. 2 is bigger than -3. -1 is bigger than -2. And so I get down to this. Where it looks like the row's only strategy is paper. And the column is either rock or scissors. But now you can see if you're only left with one row, the column player is definitely going to pick that -1. They're not going to pick that 2. And so we can get all the way down on this one to this -1, which you may recall was the saddle point. Okay, so that just so happens to be the saddle point there. Monday question?
Well, yeah. So in the very first step, I crossed out the middle column and the last row. Can I do that in one step?
Yes, absolutely. If you can do more than one thing at once, by all means do it. But I didn't want to here because it gets kind of confusing. I think this is the hardest concept of the lesson.